Okay, folks, we're moving on to question 3 of the DBE paper. It deals with sequences and series, but it deals with a specific notation in which we write our sequences and series. First of all, we see a very big symbol there. That symbol is called the sigma symbol. So let me put this information for you on the sketchboard. This symbol we call sigma. And what do we do? What does it mean? It means take the sum of the series. So we are working with a series, and now all we need to do is we need to look at whether that series is arithmetic or whether the series is a geometric series that we're working with. And folks, we find that by looking at that number over there. The number that I'm going to put in yellow, let me put it down here for you in the sketch pad again. Our sketchboard is the value of Tn. So we're talking about the term Tn, the general term. Tn is 4 times 3 to the power 2 minus k. Folks, the fact that there's a power, put it down in your tips. The fact that there's a power means we are working with a geometric sequence. Okay, so the big thing that's takeaway here is we have the sigma of Tn, and that combination means we're taking the sum of the series. Okay, so let's have a look. We first of all have to find the first 3 terms of this series to show anything about it. Let's see what they ask us to do. They say, prove that sigma, when k starts from 1 to infinity, oh, there's another huge thing to look out for. This is an infinite sequence, and only geometric sequences are infinite. So let's put that in our tips here. The infinity, we're working with the sum to infinity. And on our sketchboard, our formula for the sum to infinity is a over 1 minus r, where a is term 1 and r here is our constant ratio. So we know exactly what is going to be expected of us. Let's read on. Prove that this series that we have here is a convergent series, so that it converges. In other words, it gets to a point. And they ask us to show all our calculations for 3 marks. Okay, that's not that difficult. We must remember, for a series to converge, the big tip is the constant ratio must lie between 1 and minus 1, and obviously it can't be naught, because if the constant ratio is naught, we have no series. We have naught plus naught plus naught. Okay, so let's have a look. We first have to find out what our series looks like. So for term 1, we're going to make k equal to 1. So we get 4 multiplied by 3 to the 2 minus 1. Okay, now that gives us 4 times 3 to the 1. 2 minus 1 is 1, so our first term is 12. We have our value for a. Okay, let's find term number 2. Term number 2, we let the k value over here be 2. So we get 4 times 3 to the 2 minus 2. That is 4 times 3 to the 0, and 3 to the 0 is 1. So we have our second term as 4. Now you can work out your third term. You don't really need it. 4 times 3 to the 2 minus 3 is 4 multiplied by 3 to the minus 1. And that is 4 divided by 3. So if we want to now show that it's a convergent geometric series, we need to find the value of r. The constant ratio is two consecutive terms divided into one another. Okay, remember that. Put that on your sketchboard so you don't forget it, that the r value is term 2 divided by term 1. Now, term 2 is 4. Term 1 is 12. Well, I think 4 goes into itself once, and 4 goes into 12 3 times. So we can say that our constant ratio is a third. Now, if you're not 100% certain, you can also go and check term 3 divided by term 2. But I'm sure you will be fine by only checking the first one. But if you check the second one, 4 over 3 divided by 4 is the same as 4 over 3 multiplied by 1 over 4. Those two 4's cancel, and again you get 1 over 3. So yes, indeed, your constant ratio is not smaller than, it's smaller than 1. Why? Because it is equal to a third. Therefore, the sequence, or the series rather, will converge. Okay, that's the first part done. Quite nicely, we've got our ratio as a third. That was for 3 marks.